This is the worksheet for writing and balancing equations. The answers will be given to you as well throughout this. We'll try to follow the directions as closely as possible, but for time's sake, we might skip over some of them. It asked you to write the correct names and formulas of the compounds in the following equations and then correctly balance the equation itself. One of the things that we'll forego not doing is naming the compounds or the elements themselves, such as copper and sulfur, ones that require actual naming involved. I will actually go through and name, such as the case of Cu with the subscript 2 and the S. That means that we have a copper 1 sulfide. The reason why it is copper 1 is that 2 came from the sulfur. If you did a reverse crisscross, the Cu, the 2 would go up to the sulfur, which would make sense, and then the one that's not written in the sulfur would go reverse crisscross and go back to the copper. And if you look at a periodic table, a 2 minus on a sulfur and a 1 plus on the copper makes perfect sense. So that should work. Now balancing, as we always want to do, this one actually works out pretty nicely in that just a 2 in front of the copper will balance it out. Now the next one, we have to go from the written name to the chemical reaction, and therefore if we don't get the first part right, we're going to have a tough time going from there. It says solid copper 2 oxide and hydrogen gas form copper metal and water. So you have a copper 2 oxide, hydrogen gas, solid, that'll make more sense later, hydrogen gas, and remember that hydrogen is diatomic, to form copper metal, Cu. Metals are solid except for mercury, and water, H2O. And we'll say that out, it's a liquid, most likely. And now we have to balance it. We have 2 hydrogen on each side. We have 1 oxygen on each side, and we have 1 copper. So it's balanced as we have it written. The next one, we have sodium, oxygen, and then the other part would actually be a sodium. Oh, bell rang. Sodium. And since it's not a transition metal, there's no Roman numerals, and the 2 came from the oxygen, so it's just sodium oxide. Now this one will require a little bit more work in that we have to balance out our oxygen. So I put a 2 here to balance out my oxygen, but now that increased my number of sodium to 4. So I need to put a 4 in front of my sodium, and now that one's balanced. The next 3 problems have us working with some other stuff, and it has aqueous carbon tetrachloride decomposes to form their elements. So carbon tetrachloride. Now this is a covalent compound, so you have carbon tetrachloride, which means that it's a that in itself means that we're dealing with because of the tetra usually means that we're dealing with a molecular compound. Tetra meaning 4, aqueous is an AQ. Decomposes into its elements, so therefore you have carbon, usually a solid, and chlorine, diatomic, and it will also have the come off as a gas there. Now it needs to be balanced, but balances out pretty easily by having a 2 in front of the chlorine there. I have a total of 4 chlorine now. Next one is a little bit tough to actually name. The first one is something that it's a little bit more advanced. You have the O2 right here actually is a polyatomic ion, and that is peroxide. And so actually what we have here is hydrogen. Ooh, if I could spell right. Peroxide. Now it does require some balancing. One of the things that will make life a little bit easier for us is if we get rid of our odd number there of oxygen. Now we have a total of 4 oxygen and 4 hydrogen. Well, that can be easily alleviated by putting a 2 in front of that. The next problem has us looking at another one where we have chlorine gas and bromine liquid, sodium bromide, sodium chloride. Pretty simple to name, so I'm not going to write them out. Instead, going through the balancing process will be more important. Now we see that I needed to put a 2 in front of both the sodium and on each side. That's because what it's bonded with on either side is diatomic. So the chlorine is diatomic, and therefore we need to make sure that we have the same number on each side as that we're working with. Carbon monoxide and oxygen gas form carbon dioxide gas. Well, we have to do this one. So you have carbon monoxide, CO, mono means 1, gas doesn't mean anything to us for balancing wise. It's going to come later. Oxygen gas, so oxygen is diatomic, and form carbon dioxide gas. We now need to go through the balancing process, and like last time, it does make life a little easier if you get rid of that odd. And now I have 2 carbon, 4 oxygen, and a 2 in front of my carbon and oxygen there. Works out just fine. The next problem, we have nitrogen and oxygen gas, and I have nitrogen dioxide because I have 2 oxygen there. It's dioxide, nitrogen dioxide. I do need to balance it. I'll need to balance at least starting out with my nitrogen. But now I have 4 oxygen, which can easily be solved by putting a little 2 in front of that coefficient of 2 in front of the oxygen. Next problem, we have solid aluminum oxide. Now this one might seem a little trickier to get the right formula there, and that's because you have to do the crisscross method to get the 2 from the oxygen down to the aluminum. This decomposition does not happen fairly quickly. If anything at all, it doesn't happen whatsoever. But nevertheless, we still, for the sake of balancing and practice, we will continue. This usually would require quite a bit of the electrical to actually happen here. And again, oxygen is diatomic, and so I need to go through the balancing process. Now, I have aluminum would be very easy to balance, but I'm not going to balance that one first. Instead, I'm going to balance out my oxygen, and to do that, I need to put a 2 in front of the aluminum oxide and a 3 in front of the oxygen. That balances that out. Now that leaves me with my aluminum, which makes the balancing of aluminum pretty simple. In the last three problems here, we have aluminum, we have zinc 2 chloride, and aluminum chloride are the compounds. I say zinc 2 chloride because even though zinc is a transition metal, it is very common not to have the 2 there. I like saying the 2 because I think even though it is commonly only found with just the positive 2, I think it's much easier for us to make sure that it's done accordingly to the rules. So again, we're going to have an easy time balancing out my aluminum and zincs, but if I don't balance out my chlorine first correctly, if I can write a 2 there, because the least common multiple between 2 and 3 is 6, I'm going to have a very difficult time balancing out my chlorine if I don't balance it out first. Kind of the rule of thumb is if it's by itself, you balance it last if possible. Sometimes you have to kind of do some finagling to get some things to balance. The next one, you have bismuth and water, and then you go with bismuth oxide and giving off hydrogen gas. We can see that my hydrogen are balanced, so I don't want to mess with that much, but I can see that I'm going to have to. Bismuth should be pretty easy to balance out, so I just need to put a 3 in front of the water to balance out my oxygen. You can see that I now will put a 2 in front of my bismuth, and now that leaves me with just my hydrogen, which putting a 3 balances it out. Some might ask, well, why isn't there a number in front of the bismuth oxide? And that's mainly because we don't need to have one there. Just because it's balanced doesn't mean it requires a number. So, next one, silver 1 nitrate. Silver 1 nitrate, and that would be an aqueous solution, most likely. Reacts with zinc metal to form zinc 2 nitrate. Now this is where a lot of students get caught in that they forget to change or pay attention to the charges. Silver is just a positive 1, but zinc, because it has the 2 here, is actually a positive 2, and therefore that does not match up with the negative 1 of the nitrate. And so you have to pay attention to that. If you don't pay attention to that, you're going to have some things that will go wrong very fast. Balancing it out is not too shabby and too difficult, just a couple 2s, and it's balanced out. The real trick with this one comes on, are you able to recognize the differences in your charges? With the zinc 2 and the nitrate being just 1, the silver 1 nitrate and the nitrate it's the same on both sides, that doesn't change. So you do have a little bit of that. I hope this helped out with any questions you had. If you have any other questions, feel free to see me.